There are thousands of miles of jersey and sound barrier walls lining our nation's highways. They are an untapped source of potential solar energy generation and storage. Solaroad envisions creating a national energy system using these infrastructure surfaces. Our ElectraWall energy product is designed to be installed quickly and easily on these areas surrounding our highways. This will provide an alternative electrical source to our overstressed electrical grid. Using ElectraWall will give us the opportunity to create microgrids for power distribution when and where it is needed. Since the ElectraWall device has built-in storage, the power will be available on demand 24 hours a day. Recently, Maryland Congressman John Sarbanes spoke to the media about the potential of ElectraWall.
Suzanne Collins explains the idea is to place solar cells along the nation's highways to generate power for streetlights or construction.
Now we have no direct sunlight. We're making 331 volts.
The inventor says these circular solar collectors placed along a jersey wall gather much more energy than flat panels, even when it's a dim day or at night.
Part of the ability that we have that no other solar cell system in the world has is that when headlights strike these tubes at night, they create electricity.
The ElectraWall also stores what it collects in batteries, so it supplies electricity 24 hours a day. The inventor shows how he can plug right in, illuminating 4 fluorescent bulbs. Today, Congressman John Sarbanes, who's on an energy committee, gets a demonstration. The inventor claims 1 million feet of his collectors could match the output of a small nuke, but be cheaper and built a lot sooner.
Solaroad is developing this technology that can be deployed very quickly across the country in ways that can capture the sun and capture light.
Towson, Suzanne Collins, WJZ, Eyewitness News.
The company says the electricity wouldn't have to be distributed by the current power grid, just tapped into where it's collected.
There are jersey walls across the country, from the busiest city streets to the quietest country roads and throughout suburban areas. Many of these jersey and sound walls surround homes and businesses. This provides a perfect location for the establishment of a decentralized electrical utility. In times of peak power usage, these infrastructure-based microgrids can be used to help carry the electrical load of the local utility company. They can also provide power during emergency situations that would result in blackouts. The ElectraWall system has the potential to be the smart grid of the future. ElectraWall can be used to offset the carbon footprint caused by electric vehicle charging. We can use ElectraWall to power electric vehicle charging stations, highway lighting, traffic signals, road construction equipment, or to sell back to the grid during peak electrical demand. A key benefit of this system is that no additional land is required. Because of the vast number of pre-existing infrastructure surfaces, truly massive energy generation is possible without costly land improvements. Even this demonstration system, which was hand-installed at a local college, was done quickly and easily. For highway installations, ElectraWall can be installed using semi-automated installation machines with minimal disruption to traffic. There are many business options for the economic integration of ElectraWall into the highway and surrounding infrastructure on a national level. Some examples are: ElectraWall will be installed at the company's expense and will offer the municipality reduced electrical rates to run lighting and electrical infrastructure devices. Another option is for the state or municipality to own the installation. This will allow the state to operate it as a utility, providing electricity for themselves and for resale to the grid. Other state-owned facilities, such as buildings, maintenance shops, and parking facilities, could receive ElectraWall to offset their electrical usage. Because of its unique design, ElectraWall is the best choice for an infrastructure-based energy system. It is not practical to install flat panel solar cells on these barrier walls due to the fragility of the panels. ElectraWall was designed to handle the safety and environmental issues of a solar cell placed on the highways. In addition to the design benefits, there are many cost advantages as well, such as no additional costs for land or land improvements for installation. State and federal agencies can reduce their carbon footprint and electrical bills. Cost per watt of installed ElectraWall with storage is competitive with other solar installations providing only solar power. Provides sustainable jobs in the green energy sector on a national basis. For busy highway installations, Solaroad has designed a truck that can attach the track to the barrier wall as it drives along the shoulder. A semi-automated device follows, securing the tubes to the track. All the electrical connections will be interlocked and covered during the tube installation and will not be exposed. If a vehicle were to collide with the barrier wall and knock off the tubes, they would simply flop to the side because they're secured with a steel cable that runs through the middle of the tube. All the conductors would break away, preventing exposure and danger of electrocution. ElectraWall provides a more feasible solution to powering highway and street lighting. It would be far easier to install ElectraWall along these Jersey barrier walls than it would be to install an inefficient flat panel solar LED device on every light pole in America. Because of the massive storage capacities of ElectraWall, this system can actually power highway lighting to meet state and federal lighting requirements. In conclusion, ElectraWall is ready to be installed on a national level, beginning with pilot test beds for governments and municipalities, then expanding to the residential and commercial market. ElectraWall will create a national energy infrastructure using the highways and create lasting employment in the process.